Hi everyone, welcome to ANOVA. Chapter 7 ANOVA is the most important part in statistics, I think. ANOVA is useful in itself and will be the base of other statistical analysis method. I think I will explain ANOVA simply and systematically for you to understand what ANOVA is. Okay, let's see ANOVA. ANOVA is analysis of variance. So ANOVA is ANOVA. ANOVA is a statistical technique used to test hypotheses regarding whether there are differences among the means of three or more groups. We already studied difference between two groups, okay? Two independent population. Here, three or more populations. ANOVA is crucial because its theoretical background serves as a core engine for other statistical analysis techniques, such as especially regression analysis. For example, if you want to test whether there are differences in advertising effectiveness among three media types, SNS, portals, and radio, ANOVA technique can be applied. All right, three of them, difference among three groups. Now, let's say they are K groups in general. 1, 2, K groups, population, or say groups. Okay? They are certain prerequisites for performing analysis of variance. Prerequisite. Keep in mind, the K groups to be tested must satisfy the following conditions. They are independent each other. The K groups are independent. Second, the data in each group follows a normal distribution. Independence, normality, and variances of K groups are equal. Equality of variance. Okay? Let's see. I will denote random variables as y instead of x because it is related to the regression analysis. I think y1, first group, y2, second group, yk, kth group. And it follows normal distribution. Its mean mu1 variance sigma square. Okay. Second group, y2, follows normal distribution with mean mu2 variance sigma square. Same, equal, variance. Okay. And kth group, random variable yk, follows normal distribution with mean mu k variance sigma square. They are independent groups. Okay, we will take samples from population 1, then the sample y11 to subscript up to y1n1, n1 sample size sample from population 1. So the first subscript says the number of group, number 1. And the second subscript denotes what? The sample, okay? 1 up to n1. From second population, we take a sample. It can be denoted by y21 up to y2n2. A little complicated notation, right? Two subscript. Kth population, the sample will be denoted as y k1, k2, y kn sub k. Okay, you understand these notations? And what is a hypothesis in this case, in ANOVA? H0, mu1 equal to mu2 equal to up to mu k. Okay, these means are equal, all equal, versus at least one equality does not hold. One equality does not exist, does not hold. I will denote this alternative hypothesis as tilde H0 afterwards. Okay? Same thing. Not H0 means at least one equality does not hold. Then what will be the test statistic? What will be the test statistic for K groups? Just to think about that. After obtaining samples from K groups, letting the sample sizes be N for simplicity. Simplicity, the sample sizes are equal. It is not big trouble. But in general, you may get sample sizes, okay, different sample sizes. But here, for simple explanation, the sample sizes are equal, n, okay, no problem. Y11, Y12, Y1n from population 1, Y21, 22, Y2n from population 2, YK1, YK2, YKn, and letting the sample means Y1 bar, Y2 bar, YK bar, respectively. You will either fail to reject or reject the null hypothesis depend upon whether the differences among the sample means are small or large, right? If the differences, the sample size, sample means, okay, is small, then you may not reject null hypothesis. All the population means are equal. But the differences among the sample means are large, then you will reject null hypothesis, right? That is rational. So how can we determine how much the values of this case sample means differ, right? Okay. Since there are 3 or more sample means, the measure indicating whether the variances of the case sample means are small or large becomes the test statistic. It makes sense, I think. Okay. Sample mean. What is the sample mean? X1 bar, X2 bar, and the XK bar. They are several sample means you get. Then the variance of these sample means, variance of sample means is small, then almost all sample means are very close. And the variance of sample means is large, then what? The dispersion of these sample means is big, large, right? So test statistic in ANOVA will be decided in this sense. Okay. All right. This is the first time to of ANOVA, so I will stop here. Okay. Thank you. Bye.